Welcome to the Energy Lab of Heriot-Watt University, and today we're going to be sustainability engineers for the day. That word sustainable can mean many things to many people, and today we're probably going to focus on the resources that we use and need, but also the energy that we need to provide those materials that sustain our everyday life. So let's discuss sustainability a little bit further. You can look at sustainability in many ways. What are the raw materials that we need to extract from our natural environment to develop the products and processes that we need to sustain a very high standard of living? We can also look at sustainability in how we use the renewable energy resources that are all around us. And today's task, in a way, is going to bring both of those together. One of the key commodities that we need to sustain life, of course, is water. Good, drinkable, potable water. And while we have a plentiful supply of natural resource in the Gulf behind us of water, it isn't currently drinkable. So we have to go through a process of desalination, where we're able to extract the saline, extract the salt, and be left over with this potable, drinkable water. Now, this is a very high value commodity. It can be quite energy intensive depending on how we do it. So to make it more sustainable, we would like to integrate it with a renewable supply of energy. And that renewable energy can deliver us a very sustainable product. A product that's desalinated water that will help us sustain our lives and our community here in Dubai and across the Middle East. So today's task is going to look at those renewable sources, which is solar energy. We're going to use it as a thermal source. So we're going to use the heat from the sun to hopefully integrate it with a sustainable process and develop our potable water. Mohammed Al-Musa is going to take us through that process. And I'm really interested to see how you can innovate in your design to create very effective processes that are able to desalinate water. And I look forward to seeing what you produce.
Oh, thanks, Tyke. Now let's get into the task. Remember, our target is really to get to a sustainable and continuous process. So we are going to work out with this demonstration or an experiment that you can try out in different ways to replicate the water cycle in nature. The challenge is obviously varies based on the location you are joining us from. Certain places get lots of rain and lots of fresh water. Others actually need that fresh water. But remember, when we talk about sustainability, it's more of a global approach to sustainability. Now, being in Heriot-Watt as leading in the global research, we do come up with solutions that could be applied everywhere across our global set of campuses. You, later working in the field, could be working with a client at a side of the globe, but solving the problems for the other side of it. We all together as humans, we need to come together with the high-tech and the engineering solutions of today and tomorrow to address these issues. So let's get back to the water. We are going to produce a little bit of water today, but then you will need to think about how to increase that quantity and get more and more continuous flow of fresh and drinking water. Drinking water is part of it, but lots of industries use actually fresh water in their processes. So it's not just the drinking, that's one aspect of it, and then there is demand on many other sectors. So the task today is basically going to use water, and you could start actually with clean water, bottled water, or a tap water. We are going to add some salt to it, or typical table salt, to replicate what a seawater basically be. You could also add other things. You could add maybe food coloring and see how is that going to affect the process. What will your finished product change or not? Because part of the desalination is removing the salt, but also you have control on other content of the waters, metals and so on. Also at other sides of things, you could clean and purify water. So let's get started. Start with slightly hot water, so it doesn't need to be boiling. Maybe you could boil a water and leave it to sit for, let's say, 5-10 minutes and then get it to about 60-70 degrees. Slice up and down are okay for this basic experiment, so you don't need to be super accurate, but we want to focus on the outcome. So I have got this heated up and I'm going to use this cup of water. You don't need a scale if you don't have one, but it's good to be able to measure how much ml or the mass of water you have, so you can decide how much salt to add to make it sort of look like or taste like seawater. So I'm going to add a bit in here. And in my case, it's about 2/3 of the cup. And that's a hot water. I can certainly feel a bit of a humidity around it. This is a liquid water heated up, so I already supplied energy, in my case electricity, to add energy to that water molecules. And these heating up and then causing the water to start to evaporate. This happens in reality with sunlight. The sunlight hits and the solar radiations hit the surface of all the sea, basically the sea cover, and that will start to evaporate, and then how the water cycle all gets started. We'll need to add salt enough to make the concentration here just like seawater. They may vary slightly, so do your research. This is left to you. Do your research and find out how much salt you want to add. In my case, I'm going to zero my scale, so I know exactly how much salt to add. You could have the salt added later, initially, and then add the water. It's exactly the same thing. So I'm just going to add a bit and monitor the mass change or weight in this weighing scale. And you should be basically linking that to the quantity you need to add. Again, if you don't have a scale, that's okay. You could use a spoon and you could research what a spoon load is in grams, for example, and so on. I'm going to stir it a bit. So you could use a typical spoon or my fancy stirrer here. All work. And now I have my cup of seawater. I mean, if you are nearby the sea, you could easily go and grab a cup of seawater. I mean, this is going to be salty, so don't try to drink it at this stage. Before we move forward, this could be hot. The water will be hot. By all means, if you need help handling that, ask for help. Wherever you are running this experiment, don't take any risk, especially with boiling water. Great. So now I have a water container that has some evaporation taking place. It has salt in it. But what I'm counting on that the vapor is salt-free. Now I want to collect that in terms of condensate. I'll condense it by changing the vapor back to liquid state. I could do that simply by just flipping another cup on top. But then now the challenge will remain, how do I collect it after it condensate on the internal sides of this cup? So maybe another approach. And now I can tell you, I already feel moisture, so it is happening. You could get it then to another container, another larger container. In this case, I got this beaker. You could have a bowl at home, and you could actually do it in so many different ways. Obviously, now it's time to close it. So you could close it. Let me close this to avoid the noise. You could close it with a foil, a plastic wrap, any material available to you, or as I mentioned, another bowl upside down. And what you will see that there will be a condensate forming on the walls of this beaker in my case, or the container that you will use, and also on the cover. Now you need to think, if this condensate is collecting on there, where is it going to fall off? Is it going to fall off inside the same cup? We don't want this to happen. So how to deal with that? And how do we accelerate the process? What will happen, for example, if I just add a little bit of ice, a cube of ice, and just put it somewhere, whether in the middle or on the side, just to make a small dip that will have all the liquid, the condensate come and drop somewhere. and also to accelerate the process by being a heat sink. And what we are trying to reach here is the point of temperature that will allow the vapor to condensate. Another approach to do that is actually, let me keep this, my cover here for a second, which could work even better. This is another cup which is dry, and I'm going to put that in the middle here. But let me get my water. I think you can see now the beaker already have some condensate building it. So this is what I will do. I will put the water in the larger beaker and my dry empty cup right in the middle. And now I will just put the cover. Will move my ice to the middle. By the way, ice is not essential. If you don't have ice, that's okay. I'm making a small dip right there. So it's like this, calm down, and we'll wait. So with this approach, what I have done, basically, I have allowed a geometry for the condensate to collect on the top and then drop right in the middle in my dry cup. And you will have to wait. You will have to wait 5, 10 minutes, 15 minutes. The more you wait, you will collect more. However, remember, every system will eventually reach a thermal equilibrium, and then nothing happens after that. So the question is here, how to make this continuous? How to increase the amount of water you get? How to make it sustainable? Where do you get the energy? If I use electricity, then that electricity comes from where? Can we use solar energy maybe directly, or convert it to other type of energy and get it to this process? These are all things left for you to investigate and discover. So I'll just have a look at what I have got under this, and then I'll show you the last bit. The last bit actually is testing the water. Was this a success? Is actually the salt removed? How do we do it? I mean, don't try to drink the water unless you know it's actually a clean water. An approach which I will do, I'll prepare for it now until I collect some condensate so I can demonstrate this. So I will just get 2 small sheets of the foil I have. You could use anything, by the way, any small clean surface that you know it's clean. And here we go. And what I will do next, I will put a drop of my original water that has some salt in it, in one of them. I will put a drop on the other one and let them dry and see what happens. I'll leave this for you. I will not tell you what will happen, but give it a try. So let me see if I got anything. I don't know if you'll be able to see it on the camera. Oh, I got honestly lots of condensate there. Can we maybe show that in the camera? Maybe not. So I'm just going to get a drop of it there. Okay, perfect. And I'm going to use my stirrer to get a drop of the salt water. And just like magic, this will dry off. And what will be left over? We'll leave it to you. Remember, you could add other things to make this a bit more different and get back to your sustainability problem. We need you to save the globe.
In one way, a desalination process is actually quite simple. You've seen in the task how it involves evaporation, which actually is the separation part, because that's where you're taking the water away from the salt, and then condensation, and then, I suppose, collection. So in one way, it can be quite simple. But the real challenge will be, well, how do we do that in a very sustainable way? How do we use our natural resources to do that process? And you can look to solar for the thermal input to that process. And there are many solar solutions in which we can operate not only with high energy and high power, but also at high temperature. It is possible, of course, to concentrate the sun to get to very high temperatures. And this might help your desalination process. There are other variables and design variables that I'm sure you have been experimenting with, from the area at which you're going to be collecting or evaporating. The higher the area, generally, the higher the flux, the higher the amount of water you will desalinate. And importantly as well, you need to cool the process. The evaporation process is important, but so too is the condensation. And condensing that fluid is also a major challenge, especially in quite warm or humid environments. So design can be quite complicated, and optimizing the design in a very sustainable way is really the challenge of a sustainability engineer. So I'm really keen to see what solutions you've come up with yourselves, how to not only do it in the first place, but hopefully thinking towards how a process might be optimized. How can you make it work not just for one batch, but perhaps as a continuous flow, where you have the continuous supply of thermal power, the continuous supply of cooling, and obviously the continuous supply of saline water, perhaps from the Gulf, that's going to produce a continuous supply of potable, drinkable water. Thank you again for joining us to be a sustainability engineer for a day with Heriot-Watt University.